All right, so now we went through over chapters 15, 16, 17, 18. So I want to do a unit test to wrap up everything, to summarize what we've learned so far in the textbook, okay? And also take what you've learned out there in the lab and be able to apply it to answer some of these questions. So I've got the test, and how this is going to work is on Blackboard. I wish I had this pulled up here, but on Blackboard, you'll click on week 11, and this video is going to be on there. And so you'll be able to watch the video between Sunday to Wednesday night, and then this video will get turned off or hidden from you guys, and then the unit test will open up, and you'll have from Thursday until Sunday to complete it. And there's about 70 questions on the test, multiple choice, true, false. Okay, I don't have any fill in the blank on this one. And actually, this actually test that I'm going to go over has more questions. That's what's on Blackboard. I cut out some of the ones that are on Blackboard. All right, so I'm just going to do this a question by question. Which of the following is not a reason why aisles, and that's something I should bring up. So we're also going to bring, I have incorporated safety into this unit test as well. Okay, so we've got 15, 16, 17, 18, and then also the chapter 1, that review. And all those weekly modules, now they'll be open until Wednesday night, 11:30. So you'll be able to go back and reference those. If there is anything that is not open that you need. Now, assignments, I'll probably open up assignments just so that you can access ones that you've already taken, because the answers will be there. I didn't think about that. Well, the assignments will be there, and you're more than welcome to use that as a study guide, okay? But you can't use it for the actual test. Okay, so back to this. Which of the following is not a reason why aisles should be kept clear of hoses, electrical cables used in GMAW? And the not is the big thing. And so it's not to prevent hot slag from dropping on them. It's to reduce tripping hazards, to protect the hoses and cables from being damaged, or to keep the work area decluttered, okay, more organized. I tell you what, so I'm just going to focus on the MIG, the GMAW questions, okay? Like I said, these safety questions you've seen, so I'll kind of skim over those. Which of the following, or what does GMAW stand for? It's gas metal arc welding. In GMAW, the arc is struck between the blank and the blank. It's the electrode and the base metal. What's another name for direct current electrode positive? It's direct current reverse polarity. Which of the following is not an advantage of GMAW as compared to SMAW? And your choices are SMAW offers deeper penetration than MIG, no slag produced in GMAW, welding speeds are faster than SMAW. And those are true statements, but which one is not an advantage? And GMAW equipment is cheaper than SMAW. And it's just the opposite. The equipment is more expensive for the GMAW equipment rather than the SMAW. Which of the following is not a part of the GMAW outfit? So you got the welding rod, welding machine, wire feeder, and electrode wire. Welding rod, that's a stick electrode. What does MIG stand for? And it's metal inert gas. Metal transfer can occur in all the following modes except, so you got short circuit transfer, globular transfer, spray transfer, pulse spray, But in pulse spray, you have the peak current and the background current. And so there's no metal transfer happening during that background current. In spray, how many small droplets of molten metal form every second? And it's hundreds. What's the minimum amount of argon needed for a spray transfer? 90%. Okay, I know that we're doing 75% out there, and as I've said before, it's really not a true spray. You really, I wish I could set that up to where we do 90-10 like I used to, but we can't do that anymore. That really allowed you to see the difference between that spray transfer versus a short circuit. What happens if the welding gun is moved closer to the work? So the closer you get that nozzle to the work, the more current or the more amperage that you're putting into that piece. Which of the following is used to adjust the pressure on the dry rolls? It's the tension control knob. A GMAW or FCAW gun must perform all the functions except, and so you've got directing the shielding gas, maintain the current voltage, make electrical contact, or start and stop the weld using a switch, and it's maintaining the current voltage. The machine, the power source does that, not the gun. And then it gives you a choice of gases, which of the following is an inert gas. So you have carbon dioxide, oxygen, or argon, and argon is the inert gas. Shielding gases in cylinders have how much pressure on them? They have about 2,200 pounds in them, but I think that, so your choices are 2,000, 1,500, 500. It's 2,000 or greater, okay? The ball type flow meter, you're supposed to read the top of the ball to get your current flow. Which metal transfer produces the most spatter? And that, remember there again, you have short circuit, globular, spray, and pulse spray. And globular produces the most spatter. In GMAW, when welding arc becomes longer, the current does what? So it's the arc length that it's referring to. So the longer that arc length, then the current, it decreases. Okay, you're taking away from that current. It's just the opposite of what I was just saying earlier, to where the closer you bring that in there, the more current you got. Okay, farther away, the less you have. Ball type flow meters, they have to be installed in the vertical position. Some wire feeders have 2 dry rolls while others have 4. What can be done if the dry rolls slip while feeding? You just tighten up the tension control knob. Occasionally the electrode wire in the wire feeder will become entangled around the dry rolls. What is this called? It's a bird's nest. What type of shielding gas is used to weld carbon steel with spray transfer? And here again, this is something that we do out there with a different gas mixture. You're wanting argon with a 2 to 10% of oxygen or CO2. Okay, so you want 90% argon, 10% CO2 or oxygen. You really don't want oxygen. I've never seen 90-10 where the 10% is oxygen. It's normally a 98 with 2% oxygen, but just remember 90% argon is needed for a spray transfer. And then you've got the electrode designation numbers. And let me slide this over. Stupid cart roll straight. Okay, so your classification numbers. So this is electrode rod. And this is your tensile strength. This means solid electrode. And this is your chemical composition or usability. And this is why I was saying usability. Huh, I guess I know I just butchered that that word, usability. I'm a welder. Remember I was saying like your -2, your base metal, you have to get all those mill scales cleaned off, whereas your -6, it's gonna work better. It's always better to get that stuff removed, but the -6 will weld over mill scales better than -2, okay? So electrode rod, that means I can use this as an electrode, or I can use it as a filler rod, say if I want to use it for a TIG welding process. Your tensile strength, that's the material's ability to resist pulling forces. And then as I said, solid electrode, okay? The other classification, that was for flux core, and I didn't do a whole lot of flux core because that was primarily for another class, but I did want you to be able to identify the electrode classifications. So a flux core electrode classification would look like that. And so this still is electrode. And then this is your tensile strength times 10,000 PSI. And then this number is your welding position. And so a 1 means I can use that wire in all positions. If it's a 0, I can only use it in the flat and horizontal fillet positions. The T represents tubular, and the 1, and there again, it's your chemical composition, but it's also, it tells you if it's a gas shielded or self-shielded wire, okay? So this is flux core. And the other one was GMAW. So how that's going to work is it's kind of like a matching. It just tells you, you just have to match what things are with that particular classification number. And moving on. Adjusting the voltage and wire speed determines the what and the what. And adjusting your voltage determines your arc length. And adjusting the wire speed determines your current. Okay. What arc voltage is required when welding mild steel using short circuit, 035 wire, 20 volts. That's what we started out here, it was 20 volts. For the spray transfer, we were running about 27 volts. During welding, spatter will get into the what and onto the what. It's just your nozzle and your contact tube. It's another shielding gas question. Which defines not a recommended shielding gas for carbon steel with short circuit transfer? So carbon steel is the big thing. Carbon dioxide, 100% carbon dioxide, you can use that. You can use your 75-25, you can use a 50-50 mixture. The only thing you're not going to use is what they call a trimix, and that's a 90% argon, 7.5% argon, and 2.5% helium, okay? If the drive rolls on the wire feeder apply too much pressure on the electric wire, what will happen? Well, you're either going to get a bird's nest or it's going to flatten the wire out. Which of the following does not determine the type of metal transfer? You have shielding gas, travel speed, voltage, or wire feed speed. Your travel speed doesn't determine your transfer. All the others do. When preparing to weld, which of the following does not affect the type of welding to be performed? And there again, you got your type of metal transfer, your base metal, the metal thickness, or the manufacturer of the equipment. And the manufacturer of the equipment doesn't determine what type of welding you're going to perform. In GMAW, the voltage setting of the welding, oh, we just did that, arc length. That's a repeat question. The blank welding travel angle is called push angle, and it's your forehand travel angle. So the gun is pointed forward as you're going. The distance between the end of the electrode and the base metal is arc length. If the ripples are unevenly spaced, practice moving the gun at what? A constant or a uniform travel speed. Let's see. Blank transfer deposits more metal for any given size of electrode. That's spray. I talked about this before. I gotta get my other visual aid back here. I talked about this before. On your groove welds, you have this thing called a backing strip. And so what that is that's applied to the back side of the joint. And so you're welding all on this side. And what that's doing is supporting the weld when you make that root pass. So you can run it at a higher setting. You don't have to run it at a short circuit transfer to do the root and then kick it up to a spray. After that, you can just start out with a spray and just do the whole thing. And so it's called a backing strip. And it's used to control the penetration. I think that's the only groove weld question on the test. And the only reason I left it on there is because I know that it was brought up in one of those PowerPoints I did. When welding in the overhead, shielding gas rates need to be higher. Let's see. Which out of position weld can be made with all metal transfers? And you remember when I was saying that which welding position is the most common out of position weld, and that would be the 2F, the horizontal fillet weld. And so that's the position, that's the position that you can use all your different transfers on. Which of the following is a correct step to take if the weld pool gets too large? And that's increase your travel speed. Which of the following positions is considered to be the most difficult? And that would be the overhead. And then, like I said, there's a section here, it's just a matching. And then you got true and false. Welders must be careful to never look directly at the welding arc without wearing proper equipment, eye protection, otherwise arc flash may result. That's true. You got your fire extinguisher questions. And it's a hazard for welders to wear trousers with cuffs. That's true. Welders can be sure that the ventilation systems in welding shops are adequate to properly remove all toxic fumes, dust, dirt from the air. You're not supposed to assume, you need to take forth the energy to ask questions. Make sure that whatever ventilation system that they're providing you, that is for welding particulate, and any toxic gases or just anything like like the mill scale that you're welding over, it's going to perform, or it's going to create a toxic gas. So you want to make sure that that ventilation system is designed for that. Okay. Like I said, a lot of these are just general safety questions. A constant voltage power source is used for GMAW. That's true. The main difference between FCAW and GMAW is the electrode, and that's true. I can hook flux core wire up to that same machine that you guys are using for GMAW. The only thing I'm changing is the electrode. Well, I'm changing the drive rules, but I don't have to. I can still run that machine on those drive rules. It's just not going to be as efficient. SMAW requires more skill from the welder than GMAW. Remember I talked about it's easier to take somebody that has stick welded and teach them GMAW rather than somebody that's only done GMAW and try and teach them stick welding. Stick welding is more difficult, and so it's easier to teach somebody that knows how to stick weld GMAW, okay? It's another repeat question. GMAW equipment costs more than SMAW equipment. That's true. Voltage, current, shielding gas, and other factors determine the type of metal transfer. That's true. In short circuit transfer, the metal from the electrode enters the weld when the short circuit exists. That's true. Short circuit transfer uses a high welding current and voltage. That's false. That would be spray transfer. Some GMAW machines use a microprocessor, a small computer that controls up welding conditions, and that's true. That's what we have out there. It's those inverters. Argon is the most common shielding gas for GMAW. That's true. Now, that's not saying that 100% argon is what's commonly used. I'm saying that argon is the main component for different gas mixtures, okay, for GMAW. Argon and CO2 displace oxygen. Excellent ventilation is required to remove the shielding gases and a fresh air supply. That's true. More fumes are produced with FCAW than GMAW, and that's another true statement. You have the fluxing agents inside that wire that's going to produce a lot more smoke, plus you have the shielding gas, so all those are going to create more fumes for flux core than it is for GMAW. The two primary settings on a welding machine are voltage and wire speed. That's true. Arc voltage required for GMAW spray is higher than the arc voltage required for short circuit. True, we just kind of talked about that one. The contact tube is seen during the GMAW welding process because it's outside the nozzle. That's false. You're watching the nozzle work distance because you can't see that contact tip. When welding a butt weld, no, I took that one out, I know it. An advantage to GMAW is slag is produced during welding. That's false. Gravity can cause underfill and overlap when welding in the horizontal position. That's true. Backhand welding produces the best penetration. That's true. Excessive melting and undercutting on the vertical piece on a horizontal fillet weld may result in the electrode if the electrode is pointed more towards the bottom piece than the vertical, and that's true. And anytime you got any undercut on that vertical piece, then you want to bring the your gun or your nozzle so you're pointing more towards the vertical. You got that up, and it doesn't matter if it's GMAW or SMAW, it's all going to run true. The more vertical you run that electrode, the more chances you're heating that base metal up and you're not putting any filler wire back in there. The voltage and wire feed speed used for overhead are higher than that used for in the flat, and that's false. Protective clothing for overhead welding includes a welding helmet, a short sleeve shirt, and a cap. False. Either stringer or weaving beads can be used to fill a joint. That's true. That's why we're doing the stringers on the vertical. Stringer and weaving beads on the vertical. Okay. And so as I said, there's going to be safety questions. I'm not going to give you anything that I haven't talked about. What danger to the lungs do welders face when working in confined spaces? You got bronchitis, pneumonia, and lung cancer. I talked about that in that safety PowerPoint. What organization controls the noise? What is acceptable for noise levels? That's OSHA, Occupational Safety Health Administration. Okay, so that is the test in the nutshell. As I said, I'm going to open up those other modules to give you a chance to just go back through questions that you've already had and see any videos that I've shown. And the test will open on Thursday and it will close on the following Sunday. I don't have my calendar out. Oh, my calendar is on my phone, but you'll get, so Thursday, Friday, Saturday, Sunday, you'll get 4 days to complete the test. It's not hard. I know that I put 70 questions on the test, but a lot of them they're easy. I know that you'll get this, okay? So you guys ask me any questions, something doesn't make sense, please email me or ask me out there in the lab and I'll kind of turn it into a group lecture. Anyway, you guys have a great day.